This is part 3 of I/O ports of a microcontroller. An I/O port doesn't have to be entire port as input or output. We can use part of the port as input and the other part as output. Say, we use port B, its high nipple as input and low nipple as output. Data direction, high nipple set to 0 for the input and low nipple set to 1 for output. Data, we need to write the data to port B. However, don't forget that port B has dual functionality. For those pins which have been defined as input, write value to those bit positions. We disable or enable the pull-up resistors. Here are the pull-up resistors for the input pins. We read input data from pin B. Because only high nipple is defined as input, only high nipple in pin B has meaningful value. Other pins do not. So we need to mask those nonsense bits to 0. We use bitwise AND to achieve this. So here's the value in pin B, can be 1, can be 0. And then here's the value F0 using bitwise AND. Now, 0 in anything will be 0. And 1 in something can be 1, can be 0. Suppose it's 1, so 1 in 1 will equal to 1. And if the value is 0, and then 0 in 1 equal to 0, that means doesn't matter if it's a 1 or 0, when in 1, using 1 to end with it, will be unchanged. So those 4 bits will be unchanged. So in that way, we mask the low nipple down to 0. The high nipple, which is input from the high nipple pin, will be the value input from the pin. Now define an arbitrary pin as output and keep other pins unchanged. Here's a statement you may use to achieve that. Pay attention to the compound assignment, bitwise OR compound assignment, which means the value in right-hand side will be bitwise OR is the variable in the left-hand side, and the result will be assigned back to the left-hand side. And that's supposed to be the pin connector LED, will be predefined. Suppose it's equal to 3, and then that will be something like 1 shift to the left by 3 times. 1 shift to the left by 3 means we got a binary number with a 1 in bit 3 position. And the bitwise OR statement, suppose here is the value in DDR-B, which is can be anything, can be 1, can be 0. Now if we bitwise OR with this given value, and what is the result? 0 OR with x. If x equal to 1, for example, 0 or 1 or 1 or 0 equal to 1. So result will be 1. And if the result in this bit is 0, and then 0 or 0 is 0. So for those bits we set as 0, bitwise OR is the other value. those bits will not change. If it using 1 to or anything, the result will be 1 definitely. So that result will become like this. And in this way, the result in DDR-B will be equal to that value, those bits unchanged, those bits unchanged, but the bit we specify is equal to 1. So that bit position has been defined as an output. Here is another scenario which defines an arbitrary pin as input and keep other pins unchanged. Here's a statement to achieve this. So here's the compound assignment. You can see now is the bitwise in compound assignment, and also have a two. So once shift to the left by 4 times, we've got equivalent binary number, which is all zeros except the bit position, bit 4 is equal to 1. And then if we have a 2 in front, that means we change all bits in that value into opposite, which is this one. That will become 1, 1, 1, 0, and 1, 1, 1, 1. These are 1's complements. And then this value will be used to bitwise in with this value. And that value can be anything, can be 0, can be 1 for each bit. So that 1 in with the other bit, we keep the other bit unchanged. And only 0 in the other bit will become 0. Value now in DDR-B will be 3 bits unchanged, that be 0, and other bit unchanged. That means bit 4 has been defined as input pin. After this video clip, we are going to write a demo program to use the toggle switch connected to pin 0 of port C to turn on or off the LED connected in the same port but in pin 7. Until then, see you.